Here's something to think about. This blew me away when I first conceptualized it. It was one of the things that made me understand that psychologists are always asking questions backwards. I'll give you an example. It's like, why do people take cocaine? That's a question, right? I think it's a good question. It's a stupid question. The question is, why doesn't everybody take cocaine all the time? That's the question. Because we know what cocaine does, right? It activates the primary incentive reward systems, and almost everything you do is in an attempt to activate the primary incentive reward system. So you've got this white powder and there it is. It's like you should be nose deep in that stuff non-stop. But you're not. Why? What's wrong with you people? You know? So that's one example of where psychology's got it backwards. We know why people take intoxicating drugs. It's dead simple. Sometimes it reduces their anxiety, sometimes it reduces their pain, sometimes it cranks up their incentive reward systems, you know, it hijacks the system, it does it biochemically, it's perfectly obvious. So that's one example. Now another example is this. How do animals learn fear? It's a prime behavioral question, right? It's the wrong question. Because it presumes that the standard animal is calm. Why would you presume that? Why wouldn't we presume instead that the standard animal is terrified? And that the animal only learns how not to be terrified with difficulty and under very restricted circumstances? Well, that's a much better way of thinking about it, and it makes a lot more sense because the animal's in danger, especially if it doesn't know its territory. So here's how you teach an animal to be afraid if you're a behaviorist. And I am not making fun of behaviorists. A lot of what I've learned about psychology that's actually real has come from behaviorists. Like, they're rigorous scientists, and they learned an awful lot from analyzing animal behavior that was incredibly profound, and they laid the ground for modern neuroscience. The real stuff, not the fMRI stuff, you know, the real stuff. So, okay, so basically what you do to train an animal to be afraid is you take a rat, let's say, and the rat's in his cage, and you put a little electric shock pad in the rat's cage, so it maybe electrifies the bottom a little bit, and you turn on a light, and you electrify the bottom, and the rat jumps into the air, and then you shut it off, and then you wait a while, and then you do the same thing. Turn on the light, then you turn on the electric shock mechanism, and the rat jumps in the air, and you do that 10 times, and then when you turn on the light, the rat goes like this, freezes, because it's learned, right? Light equals shock, everyone knows that, you know, that's basic conditioning. So the rats learn to be afraid. Okay, that makes sense. Except, here's your experimental box, right? You got the electrification going on in there, and you grab your rat and you drop him in the cage. What does he do first? He freezes. Because he's afraid. He's afraid as soon as you put him in the new environment. That's the normal rat. The normal rat is like this, and why is that? Because things like to eat rats. So, you know, they don't like light, they like it dark, and they don't like being exposed, and they don't like being in a new damn cage, because God only knows what's in that cage, and so the a priori rat is this. So then what does the rat do? Well, it's like this for quite a while. It can be really a long time. I'll tell you a story about that. He's like this, and then maybe he sniffs. Because rats mostly nose. Most animals are mostly smell oriented, right? Human beings are weird because we're visually oriented, but almost all animals, it's all smell. Their whole brains are organized around their olfactory system. So it sniffs, and if it can't smell anything, rats, man, they can smell. So there's experiments indicating that if you take a rat and you poison it, and then it gets sick, and another rat has smelled its breath, that rat will not eat the poison that the first rat ate. Now that's why it's hard to get rid of rats. They're smart and they have great senses of smell. So the rat's checking out, like, is there anything here that smells like something that might eat me? So cats, for example, a rat doesn't ever have to meet a cat to be afraid of its odor. Rats hate cat odor. And so you can take rats in like a box and blow a fan over a cat so that the odor wafts into the box, and it's like the rats are all like this because God only knows what a cat smells like to a rat, but it ain't good, whatever it is. So the rat's like this, then he's sniffing, and he's looking around, and if nothing happens, Then he starts to relax a little bit, but not that much. He's still all crouched down, and he's still like a tentative rat, and then he starts to look around a bit, and then he starts to loosen up, and then maybe he starts to move, and his theory is, possibly it's safe enough here so a rat that's careful can move, and nothing painful or damaging will happen. And then he starts to move, and nothing happens, and then he spends a bunch of time sniffing around every corner of the cage, and you know, sooner or later he thinks, rats aren't going to die here now, and then he's sort of a relaxed rat. And then the behaviorist says, you are now a normal rat. We can teach you to be afraid. It's like, you don't have to teach me to be afraid. I know how to be afraid. I have to learn how not to be afraid. Now that's a good way of thinking about your brain. So you could think about the underlying motivational and emotional systems in your brain as default on systems. They're like a nuclear reactor, like the core of a nuclear reactor. You're ready, man, except when other parts of your brain are telling you just to keep it calm. So, but you don't need to learn to be afraid any more than you need to learn to be hungry. You need to learn how to be calm and secure.